Good day, students. On this clip, we're going to be reviewing two problems on how to solve quadratic equations. The first one will be by factoring, and the second will be by completing the square. Okay, so let's write down the title of the notes. Pre-quiz review. Pre-quiz review on solving quadratics. Quadratics by factoring and completing the square. Here, completing the square. Okay, so for the first example, we're going to do is the easier of the two, which is factoring. But in that procedure, we're going to include a graph in our solution. Okay, so the instruction is as follows. For the first one, solve the given equation. Solve the given equation by factoring. Then sketch a graph of the function, okay, the related quadratic function. All right, let's do it. So the first one we're going to look at is the quadratic equation 6x squared plus x minus 15 equals 0. Okay, so this equation is already placed in standard form for us, so we don't need to move anything to anywhere to find a and b and c. So all we need to do is we have a trinomial here. We want to change it into a polynomial in 4 terms so we can factor by grouping. So we're going to use the x game to help us determine the two numbers that can make this happen. So AC goes on the top, B goes on the bottom. AC is negative 90 and B is positive 1 because the coefficient here for B is positive 1. Okay, so this is A, that's B, and that's C. Alright, so what two numbers multiply to give you negative 90 and add to give you 1? Let's make our t-chart and look at the multiples of 90, okay? So I know 1 goes into 90 times. This doesn't work. This is 91 or 89. 2 goes into 90 45 times. This is 45 or 43. That doesn't work. 3 goes into 90 30 times. This gives me 33 or 27. That doesn't work. 4 doesn't go into 90. 5 does. 5 goes into 90 18 times. That doesn't work either because that gives me 13 or 23, which is not what I want. What next? 6 goes into 90 15 times. This gives me 21, or if I minus it I get 9. That doesn't work. 9, 7 and 8 don't go into 90. 9 goes into 90 10 times. So that's all. This is everything we have. Oh, voila, there you have it. So 9 and 10 works perfectly. So we're going to use 9 and 10 to resolve the sign. The product has to be negative and the sum is positive, so the smaller of the two will be negative. Negative 9 plus 10 is 1, negative 9 times 10 is negative 90. Alright, so plugging those two in here, we have 6x squared minus 9x plus 10x minus 15 equals 0. Break it down to standard and factor by grouping. That's going to yield, or let's break everything down. We'll have 2 times 3 times x minus 3 times 3 times x plus 10 is 2 times 5 times x, and then 15 is 3 times 5 equals 0. On the left side we can take out 3 and an x, so we'll have 3x times 2x minus 3. On the right side I can take out just a 5, and then I always bring down the middle sign, okay? Bring down that sign, plus 5 times 2x minus 3 equals 0. This is where freeze and check. You see these two quantities identical, so our solutions are correct so far. So I'm going to factor this, and this is identical to 1, 2x minus 3. And then what you have on the outside, I'll bring them together. This one and this one, bring them together as 3x plus 5 equals your fractal form. Now we're going to use the zero product property to finish this off. So the product of these two quantities are 0, either the first is 0 or the second is 0. Alright, so now using the properties of algebra, we're going to solve isolate x. So if I solve this, I'm going to have x equals, add 3 and divide by 2, 3 over 2. Or minus 5 divided by 3, here we're going to have x equals negative 5 over 3. So our solution set is 3 over 2. Oh wait, I got to write a small one first. Solution set is going to be negative 5 over 3, comma 3 over 2. There you have it. Alright, so let's make a sketch of the graph of our solution and indicate where the zeros are at. Make a y-axis and your x-axis. I'm going to calibrate my axis by 3's, okay? So 1, 2, 3, that's a 1. 1, 2, 3, that's a 2. That goes your x-axis. 1, 2, 3, that's a negative 1. 1, 2, 3, that's a negative 2. This is your y-axis right here. So our first solution is negative 5 over 3, which is the same to negative 1 and negative 1 and 2/3. So we're just going to go negative 1 and 2/3. There goes the first 0. And then the second 0 is 1.5. So 1.5 is right in the center here. The y-intercept, let's just call it low somewhere down here. The y-intercept is your c, right? It's this value right here. Your c up here is your y-intercept, negative 15. So right here, we just call that negative 15. And then draw a parabola as best as we can, intersecting through there, going through there, and going up. And then the other one curves. Oh wait, that's terrible. So try and make it as smooth as you possibly can. Goes through there. Remember, this is just a sketch, it's not perfect. And then it goes up forever. Alright? Alright, so this is a 0. X equals negative 5 over 3. Negative 5 over 3. And then this is the other 0 right here. X equals 3 over 2. Okay? So there you have it. Alright, let's move along to the second question, number 2. Solve the given equation by completing the square. So solve the given equation by completing the square. And then check the accuracy of your answers. Check or prove your answer is correct. Prove your answer is correct. Okay? Alright. Alright, so the question that we're going to be working on is x squared minus 6x plus 27 equals 0. Okay? So this one is already in standard form for us, so we're just going to go ahead and start applying the completing the square algorithm. Alright, so to do that, first of all, we have to create an incomplete square on the left side. So we need to move 27 to the right, subtract 27 from both sides. And then we'll have x squared minus 6x equals negative 27. Remember, x squared plus or minus bx is your incomplete square formulation. So you always have to have it like this first before you complete the square. Okay, now we're going to add b over 2 squared to both sides. B over 2 squared is how you complete the square. So in this problem, b is negative 6, as you can see here. Negative 6, what do I do with that? I divide it by 2, which is negative 3, and then I square it, which is 9. This number completes the square, alright, on the left side. So I'm going to have x squared minus 6x plus a 9. That completes the square. On the right side, negative 27 plus a 9. This is a perfect square trinomial, so I can factor either using the X scheme or the trig. I'm going to use the trig here. Read the first, read the last, and bring down the middle sign. Okay? Alright, you're going to have x minus 3 quantity squared equals, if you add these two together, you end up with negative 18. Alright? Now this is where you're going to take the square root to get rid of the square that you generated by factoring this perfect square trinomial. So what I'm going to do is I'm going to root this and root that. On the left side, anytime you take the square root of a square, you end up with absolute value, x minus 3. And then let's work with this. If you have square root of negative 18, the negative comes out of the square root as an I, because we know that I is root 1. So we break down 18, we have 2 times 9, and then 3 times 3. This 2 is alone, so it stays behind. These two 3's repeat, so they break out as 3. Alright? So the reduced form of the root negative 18 is 3I root 2. Okay? On the left side here is going to be 3I root 2. To get rid of the absolute value, we'll replace it with plus or minus per the definition of absolute value equals 3I root 2. Divide both sides by plus or minus 1. Plus or minus 1. Plus or minus 1 to move the negative and positive to the right. So we're going to have x minus 3 equals plus or minus 3I root 2. Okay, now we're going to split the equation into two. We'll do the negative part and the positive part. Alright, so we have x minus 3 equals negative 3I root 2 for the negative, or x minus 3 equals positive 3I root 2. Okay? Alright. Alright, so let's solve them one by one. So we're going to have this one, just add 3 to both sides. So your first solution is going to be x equals 3 minus 3I root 2. And on the right side, just add 3 again. And you have x equals 3 plus 3I root 2. So your solution set is given by 3 minus 3I root 2, or 3 plus 3I root 2. Okay? Alright, now let's prove that our answer is correct. Okay, we're going to prove that our answer is correct. Proof that 3 minus 3I root 2 and 3 plus 3I root 2 are solutions to the original problem. What is the original problem? X squared minus 6x plus 27. Okay, so we're going to start by testing the first one. Test x equals 3 minus 3I root 2. Alright, so let's go ahead and do that test. To do that, we're going to plug in this solution into the x's. So we're going to have parentheses 3 minus 3I root 2 square minus 6 times 3 minus 3I root 2 plus 27. It's supposed to be equal to 0. So the question is this expression equal to 0? Is it? Alright, let's work this out. So I'm going to write this twice. 3 minus 3I root 2 times 3 minus 3I root 2. And then distribute negative 6 to these two terms. So I'm going to have minus 18 plus 18I root 2 plus 27. Is that equal to 0? Is it? Alright, let's FOIL out the first term. The first two terms on the left. We're going to go first. If I do first, I'm going to have 9. If I do outer, I'm going to have negative 9I root 2. If I do inner, I'm going to have negative 9I root 2. And when I do last, I'm going to have positive 9I squared. Root 2 times root 2 is just 2 times 2. Okay? And on the right side, I can combine negative 18 and 27. So let me bring this down. This is going to be plus 18i root 2. If I combine negative 18 and 27, I'm going to end up with positive 9. So this whole story, is it equal to 0? Alright, let me simplify the left side a little bit more. So I'm going to have 9. I'm just going to add this one downwards. I'm going to draw a line right here. So I'm just adding these foiled pieces together, okay? So it's going to become 9 minus 18i root 2. So this I squared is negative 1, changes this to a minus. 2 times 9 is 18. Okay? Plus 18i root 2 plus 9. Is this whole thing equal to 0? Is it? You notice these two are opposites, so I can cancel this and this, the 18i root 2. 9 minus 18 is negative 9. Is negative 9 plus 9 equals 0? Is it? Absolutely, right? Because 0 equals 0, so that checks out. Alright, so that's for the first test. Now we have two solutions, so we have to do two tests to verify the accuracy of our result. So now we're going to test, x equals 3 plus 3i root 2. Okay? Same story, plug it into the original problem. Question is 3 plus 3i root 2 square minus 6 times 3 plus 3i root 2 plus 27 equals 0, is it? So this one we're gonna write it as a product. So we're gonna have 3 plus 3i root 2 times 3 plus 3i root 2, and then distribute negative 6 to this and that, minus 18 minus 18i root 2 plus 27, is it equal to 0? Is it? Alright, so here we're going to follow this out as we did before. If we do the first, 3 times 3 is 9. If we do the outer, 3 times 3i root 2 is positive 9i root 2. And when we do the inner, it's going to be positive 9i root 2. And then when we do the last, it's going to be plus 9i squared. Root 2 times root 2 is just 2. Okay? And then I can bring down negative 18i root 2. When I combine negative 18 and positive 27, I'm gonna get positive 9. Okay? Alright. Now let's combine this foiled out terms here that I did over here. Let's reduce that. So I'm gonna have, just bring down the 9, there's nothing to add on to there. These two add up to 18i root 2. And now I squared is negative 1, so you have minus. I squared is negative 1, so this becomes minus. 9 times 2 is 18. Minus 18i root 2 plus 9. Is it equal to 0? Is it? You notice these two are opposites, so they cancel out. So we're going to have, is 9 minus 18 plus 9. Is it equal to 0? Is it? 9 minus 18 is negative 9 plus 9. Is it equal to 0? Absolutely, 0 is equal to 0. So our answer checks out. So thanks so much for watching this video. Please subscribe to my videos and share with your friends via Facebook or Twitter. You can find a collection of videos on mathyourself.com. Thanks again and have a wonderful day.